Hi, everybody who's here. Thank you for joining. This is our first information session hosted by All Control and SICK. My name is Jim Staniszewski. I'm the Director of Sales and Engineering at All Control. Today we have SICK Application Specialist, Russ Nicodem. He's going to be discussing solutions for safeguarding robotics applications and specifically focusing on SICK's sBot solution package. It's a package that combines uses a combination of safety controls and area scanners so it can dynamically guard a working area. This can eliminate the need to restrict access by physically surrounding the cell with actual physical walls. For those of you who are unfamiliar with SICK, they're a manufacturer specializing in sensor intelligence. This includes safety, detection, automatic identification, and other sensing technologies that are used in pretty much all manufacturing industries throughout the world. All Control is a local technical resource and distributor for SICK, and we've represented SICK for 30+ years. We have a group of sales and application engineers locally in Illinois, Wisconsin, and Indiana, and we can assist with pretty much any and all automation applications. We know that recently most of the way that we've worked has changed quite dramatically. So we thought these technology and solution updates would be good to get out to our customers while in-person visits might be limited. So keep in mind, these are informal sessions. We're definitely not pro webcammers. So feel free to chat in questions, comments, or any thoughts as they come up. At the end, like I said previously, we'll open it up and unmute everybody so we can get questions if you want to ask Russ or any of the All Control people. This is the first session, but in the months of May and June, we have a couple more on the schedule already, focusing on safety applications and solutions. So hopefully you've heard about them already, but look for more information about future sessions in the coming days. So now I'll introduce Russ Nicodem, who's here to explain some new and easy methods to safeguard your robotics application.
Thanks, Jim. I sure appreciate that. My name is Russ Nicodem. I'm the safety application engineer out of Wisconsin. So I handle Wisconsin and Illinois for our safety products group. Also can help with safety services as well if you need risk assessments or safety concepts or validation or things like that. But my main focus is the safety products group. So today we wanted to talk a little bit about Safe Robotics and the kits that we have put together to make implementing a safe robotic system simple and easy, and to make sure that you're meeting all of the applicable standards. So we'll jump right into this because we only have a half hour and we want to be respectful of your time. Anybody who wants more information or wants to stick around, I'm around. I've got all day. If you've got questions, I'm here for you in my home office in Appleton. So always here if you need me. Feel free to contact any of us and get a hold of me. We can talk in more depth. So today we're talking about an sBot. sBot stands for Safe Robotic Area Protection. So what is it? Its main purpose is to increase productivity, as you'll see in these demos. It's a system that is designed to give you free access to your robot, and be able to allow your robot to be working using speed and distance monitoring as its main safety plan. We've got these systems put together so they're easy to integrate. You'll see when we do this that you have the hardware and the software. It all comes as a kit with the E-plan and your Sistema files and everything together, so that you don't have to be a safety engineer to put these systems together. We've done them for you to ensure that they meet the applicable standards. What we're talking about here is primarily cooperative robots. In our world, and people have the terminology mixed around, there's cobots, and cobots typically are using speed and force monitoring. Those are the ones that work directly with people, and you can touch the robot. That's speed and force monitoring. We work with those as well. So the system is applicable for cobots. Cooperative robots are the main focus, and that's 90% of the robots on the market. Those are your industrial robots that share a common space with an employee, and we'll show that. And then there's coexistent robots, and those are the ones that Jim was referencing in his opening that, hey, you put gates around them. It's kind of like living with my daughter downstairs. We coexist. You don't want to go in her room, and she doesn't want to come in mine. That's the coexistent robots. And that isn't so much the focus of our discussion today. So we're primarily focusing on cobots and cooperative robots. And some people get it confused and think we're only talking cobots or only talking cooperative. No, these systems are designed for both of those styles of robots. So today there's a couple different kits that we've put together. In our world, we talk about there's sBot, remembering sBot is Safe Robotics Area Protection. There's a stop, which is brand new, and it's generic. So it's for most general robots that you might have on the market that may not have speed and force monitoring, or they don't have safety rated speed monitoring. They just have a stop function, and you just want, if somebody walks into the cell, you want them to the robot to come to a controlled stop, and then while a person's in the cell, stay stopped. That's called an sBot stop. And if it's called generic IO, that means that we're using just inputs and outputs. Then we jump into the speed family. So there's two families. There's stop and then there's speed. When we get into the speed family, we also can say it's speed with general IO. That means you don't have a safe network. You're just using inputs and outputs, which is what I'll be showing in my demo here. And then we have a speed, still in the speed family, UR. That's a kit specifically designed for cobots, and it's called UR because it's all of the E-plans and all of the documentation are specific to the UR robot. And then one of the next new ones, and why I highlight these four is because they're all different, is the sBot Speed FA, which means FANUC. So it's designed specifically to work with FANUC. And what makes it, work with FANUC versus others, really it's the instructions. You write up the instructions, and in this case, it's going to be that they're using Ethernet SIP safety. So they're going to be over the network. We're going to focus on that a lot. There'll be a sBot Speed YA, that'll be a SCOW. You can get an sBot Speed IO, which is this one over here, which if you don't know, if you don't have one of the main brands, most likely the generic IO version will work for you. So we've got them set up for generic, we've got them set up for very specific robots, as you'll see. So it's a really nice kit, especially, well, even if you just have a generic, any type of robot out there. So one of the first variants, this one's not the most exciting, it's your traditional way of stopping a robot. This is called the sBot stop. You'll see that there's a light curtain at the entrance to the robot cell, and then there's a laser scanner inside the cell. The light curtain is your primary protective measure, and then you've got the scanner inside monitoring so your machine doesn't restart while somebody's inside the cell. And then all of the logic for these are done in a simple logic controller that doesn't even require a computer. All the logic is inside this little relay here. You can get these, the traditional way of safeguarding a robot would be a manual restart, but you can also get it with automatic restart. And that's why you've got a safety laser scanner inside the cell that's monitoring it, that if somebody's still in there, when somebody exits the cell, the logic says, hey, somebody entered the cell through the light curtain, stop the robot. Now they're still inside there, keep the stop. And then when they exit, you've got a choice. Either they push the reset button or you can have it automatically restart. What we're showing here is that we're combining, the whole concept here is that we're combining a bunch of our technologies. We have the safety laser scanner, a light curtain, plus the controls, and then your logic is inside the controls. And then we also include instructions for the system so that you're not going back and forth. Oh, I need to read the instructions for the safety scanner. I need to read the instructions for the light curtain. I need to read the instructions for the controller. we put that together into one set of instructions for the system. And then we ensure that the system meets performance level D, which is the safety rating for the robot cell as a system. So this would be your first way of interface. You'd have your emergency stop going into your robot. You would have your laser scanner, your light curtain going into my little controller, my reset button in my controller. My pendant goes to my robot. Very simple architecture. And that's if you have a robot that just has a protective stop. And every robot would have a protective stop, should. And this would be your most simple way of safeguarding a robot cell. And then it would be just a stop. And then when you exit, you restart. If you wanted to step up to having it be automatically reset, then you have to look at your robot controller and make sure it's got an emergency stop and a protective stop. So somebody pushes the emergency button, it goes into the emergency stop function, and that is not an automatic restart. But if somebody enters the cell properly, comes in through the light curtain, is in the laser scanner area, and then exits, the system knows that everything is clear, and the robot can automatically start. So the idea here is that the safety functions are available through pre-engineered and tested safety logic. That's really important. They're simply selected and simply select the correct program on the Plexi Classic, and you're up and running. So these are really easy to get up and running. They're reliable, performance level D. You get detailed documentation for the system, not just each component, and it'll work with most industrial robots. So this is just your basics, sBot stop is just the basic system, and it's more the traditional way of doing robotics. You could do this all day long. The nice thing about buying this kit is it doesn't cost much, and you know that it meets performance level D, and you didn't have to do the logic. When I talk to big companies, those are the things that they like, that their robots are all going to act the same because they all have a baseline of logic built in, and they don't have to worry about, hey, I've got 10 different integrators and they're all programming my robot differently. So each robot acts a little different. So what we really want to talk, which is way more exciting, is the sBot Speed SIP FA FANUC. So I chose the FANUC because it's the latest one that we released. And keep in mind that this will work on other variants, but this one, because it's using Ethernet SIP safety, that's the newest and latest and greatest safe network. And FANUC's a good manufacturer, so it's a great one to spotlight in this demo. But to give you an idea, we do work with all the other, many of the other large robot manufacturers. And what this chart is trying to show is if you call me and say, Russ, I've got a FANUC robot, I'm going to say, what type of controller you've got? I go to the second step and, oh, I've got an R30 IB or an IB plus. Okay, that's good. We have a system for you. Do you have IO, or did you buy the DCS, which has the Ethernet SIP safety? Yes or no? Oh yeah, I've got the Ethernet SIP safety on mine. Perfect. We're right into our sBot SIP FA, and I know that we can integrate directly to it. If you have a different robot or a different model, you just let us know what you have. But those are the basic stuff that we typically would want to know. Is do you have IO or do you have Ethernet SIP safety? Same for Yaskawa. Usually you'll have the DX200 or the YRC1000. It's either going to have IO, and usually the Ethernet SIP safety can be an option. So I don't always know if you have it. You may need to know that. And if you want to go with Ethernet SIP safety, yeah, that's something you're going to want to be able to tell me, and we'll be able to integrate right in. If you've got a UR robot, we've been working with UR forever. Keep in mind, UR, is mainly a cobot, so they'll use their speed and force monitoring. But the idea when they combine it with our laser scanners, then we use distance and speed monitoring, so that when you walk away from the cobot can go into full speed, and then when you walk up to it, the cobot goes into its collaborative mode. That's the idea. Otherwise, the cobots are so slow that you can't get any production out. So we're working with ABB, KUKA, and we work with most brands. What we have listed here are just like the ones that we've written up the instructions for, and we work with regularly. So if you have a different brand, well, let me know, and we're, most likely we can work with you. So what's the idea here? This is a system, and it's a system that you can deploy. It's not a system that you have to hire a safety engineer necessarily to do. It's made for cooperative robots, and it's made for those robot applications that you need free access to the robot. In this case, we're talking about the FANUC. And one of the things that to keep in mind, sometimes people think, yeah, my robot's got Ethernet SIP safety. Yeah, I've got a laser scanner right here that's got Ethernet SIP safety. Why don't I connect the two together? Well, the robot is the FlexiSoft, there has to be something in the middle. There has to be a master. So the FlexiSoft, which is our controller, acts as the master going between the laser scanner and the robot. So that's what they're trying to get into here. The FANUC is the target or a slave. Our system is the originator or the master, and it coordinates the communication between all the devices over a safe network. One of the most common robots, FANUC robot controllers, is the R30IB. A lot of times you'll hear the word, hey, do you have a DCS? That's their dual check safety. They've had it out for a while, and that is that's what they call their safety system, that has the safety rated speed monitoring, has the safe stop and the protective stop. And then if you've got the DCS, the next thing, the option that you can buy is usually the Ethernet SIP safety. So if you have DCS and Ethernet SIP safety, those two words mean a lot to us. You've got a really nice case for putting in one of our canned solutions, which I'll be showing you even in more detail. A couple of examples of how you might use the free access to your robot cell. One of the things on this slide that they're talking about, when you go with the Ethernet SIP safety, all of the fields are safety fields, which is, first of all, really nice. So when this person walks into this protective field, the robot will have a DCS, which means that it knows its speed and position. It knows how fast how fast to go and in what coordinates to move in. When the person goes into the second zone, the robot may slow down more or stay in a different area. But a lot of people don't see there's a little area right down in here by the robot, which is super close. It means that somebody's scooching behind, and that would be like a no-go zone, and the robot will go into a emergency stop saying, hey, somebody just went where they're not supposed to. They're supposed to stay in zones 1 and 2, but they entered 3. Sorry, you can't do that. And then when you exit, you have to check the cell and then push your reset, which would be your normal way of resetting. So we keep beating on this a little bit. Unlimited free access, simple and low cost. When you go with Ethernet SIP safety, the nice thing about it is this is your wiring. Literally, all of your I/O is over your Ethernet cable. I have one set up in my lab. I'm not a Ethernet a PLC programmer, and even I can make these things work. When you see the software, it's really well written. You'll find that it's reliable. And if you've got a plant that's putting in a lot of FANUC robots, the big draw to the end users, like the Unilevers and Nestle's and things that they tell me that they really like, is that the system comes with a baseline program in it. So all their robots, if they're rolling them out across 400 plants, they all at least have common hardware, common software, and a common functionality. You can build on it, but at least you have a baseline. So that's what we're talking about, being flexible and future-proof. These things are not locked down. The program's not locked down. You can build on them, but you always have a baseline, and you can keep adding, and you can even be deducting but the base program and the base is already set for you. So what does the system look like when we jump into FE Pro, which is our name for Ethernet SIP safety? So we've got a controller in the middle. You've got a laser scanner on in the cell, and then it's communicating to the robot, to the Fennec robot, over Ethernet SIP safety, which is the safe network, and the robot is communicating back both on the Ethernet SIP safety, but it's also communicating non-safe data via Ethernet IP, so they're communicating back and forth, so that the controller is telling the robot, hey, this is what my laser sees, and the robot saying, got it, I've slowed down, and then the scanner says, okay, so now I don't have to look so far. So they're communicating back and forth, and making it so that you can work closer and closer with your robot and still get productivity out while staying safe. So what do you get? There's a couple different things you have to buy. So you buy a software package. Your software package will include your laser scanner program, your safety controller program, your Systema files and your wiring diagram, etc. Then you buy your hardware kit, then you get your operating instructions. You'll get your laser scanner, you'll get the right program, your right CPU, the right gateway. So you get all the right stuff. You're not guessing, oh shoot, did I buy all the right accessories? It comes in a kit. So here's going to be a homemade video that I made, just showing the concept of my demo right here.
Welcome to the Tech Desk of Russ Nicodem from SICK Incorporated. Today we're going to be talking about an sBot. So what is an sBot? An sBot is a safety robotic area protection kit. It combines a bunch of our technology into a comprehensive safety robotic kit. So it includes a safety laser scanner, safety controls, whichever controls would be applicable for your robot. You normally have the e-stop and reset buttons incorporated in. It has the program for the laser scanner, the program for the safety logic, which is specific to your robot. But this is called a speed because it has custom function blocks built in. So if you notice here, I have a yellow zone, which is my warning zone, which is my slow down zone. I've got a protective field 1 and I've got a protective field 2. So the idea here is that your robot can have free access to it, and the controller has built-in logic so that when a person enters the robot cell and they get into the first warning zone, it uses speed and distance separation as a safety measure. It sends a signal to your robot to slow down. You notice that your robot now is going very slow. That takes this protective field and it shrinks it because it gets feedback from the robot that says, hey, I'm slowed down. So now my person can work around the robot much closer because the robot is moving slower. If the person gets too close to the robot, it still stops. You can see that it stops, and the person does his chore, and as he backs out and gets into the warning zone, the robot automatically starts back up. That's why it's called a speed. It has sequencing built in. And as he backs out further, when he exits the cell, the robot automatically goes back to full speed without the need of pressing a reset button. So you say, well, what happens if he breaks the sequence? So the person comes into the cell and he's working around and something drops and he goes into the protective zone. And if he breaks the cycle, you'll notice that my reset button comes on and the automatic restart is gone. So then when he leaves the cell, he has to physically check the cell to make sure everything is okay and push reset. So that's what the custom function block is doing. It's doing the sequencing. Once again, he allows the person to come into the cell. The robot slows down, allowing him to work around the cell. And when he gets closer, it stops. And then as he exits, it goes back to slow speed and then ultimately back to full speed, increasing your productivity. So that's at the heart of the sBot speed. Thank you and have a good day.
So that was a quick video. I just shot. It's sometimes easier to show a video than it is to try and do this live. Will do a quick live here as well. Try and move along here. So what the idea is that we're offering is safe productivity. That's the biggest thing, because the robot is able to keep working while a person is in the area. It's cost efficient. These systems are not, extravagantly expensive. The thing that the heart of this is the safe sequence monitoring. The standards require that if you're going to do the automatic restart, you have a safe sequence monitoring, and we do build that into the controller. And that's the only thing that is locked down in our controller is our safe sequence monitoring. So we make the integration easy. We pre-configured the files, so you get your software. We give you the right hardware kit. We set up your communication for you. We give you software logic. We set up the compact hardware set. After this, I'll show you that we actually make the connections between all the devices, which is usually the hardest part of making these systems work. So we do this. I want to exit. So what I have on the screen now is what you would get if you bought when you buy this sBot Speed FA. This is the file that you would get downloaded from the internet. So what's under the hood. This would be your hardware set. You can see you have very limited I/O. The only I/O you have really are your reset buttons and your e-stop. All of your communication to the laser scanner and to the robot are done over this, what we call FE Pro, which again is our Ethernet SIP safety module. So when we get into this is just showing the next configuration screen. So in the logic, let's jump into this real quick. So you'll be able to see that this is the logic that is written for you. I just simply downloaded this from the internet. This is what you get straight out of the download. So you've got your I/O data. There's your I/O summary, giving you your inputs, your in and outs, your protective stop, your safe sequencing, your robotic safety in here. This is just an overview page of what's going on under the hood. The description is just your disclaimers. On the next tab is they really did a nice job breaking out the software and giving you notes, inputs from the safety laser scanner, discrete inputs from your XTIO. This is nothing that I created. This is what you get when you download the software. And this is in the safety controller. What does my emergency stop look like? In and out, sending my signal to my robot. What's my protective field? So you can see, I like to show people what they're getting. If you had to write this program, the software is, I think, maybe $1,500. If you had to write this program and do it correctly, you could spend days getting it right, and then you would probably need to run it past a safety engineer to make sure that it meets all the right standards. So the beauty of it is that this software is written to meet the RIA standards, and the system is set up as a performance level D, which is what you need for your robot. Let's see if I've got one here. Should be ready to go. So this is my actual demo running. When I open the logic, it opens in a different screen. So in here, you'll be able to see, you just see things happening. So if you are live, you can see emergency stop. That's just showing my my robotic system live. So I know we're at about a half an hour, so I wanted to open this up for discussion. I'll do a quick demo of the system. So I'm going to stop sharing my screen. One quick, yeah. So stop sharing my screen. So what I have going on here, this is my sBot. This is the robot. And just like we showed in the demo of the video, your person walks in and my controller knows that that somebody's in the area. The robot slows down. It allows him to get really close and work around the robot cell. This is an I/O unit. That's why it has so much I/O, because it's sending signals back and forth to the robot and monitoring speed. It's having the robot monitor speed, but getting feedback that it's going slow and that it's slowed down, that it's a protected speed, that you're in sequence. There's a lot going on inside there. This one I have set up because this would be exactly what you would get if you went over Ethernet SIP safety. And that's really the way, if you can go that way, I highly recommend doing Ethernet, SIP safety. So with that, I just wanted to show one thing here, just to give you an idea. Yeah, I forgot one thing. So you can see my screen again. We were talking about with Ethernet SIP safety, everything is in one suite. That's the other thing that's nice. You don't have to have a Rockwell PLC over here, a FANUC controller over here, a SICK laser scanner over here, and 3 different softwares. Everything is in one software suite. So here's my FlexiSoft controller. Here's my safety laser scanner. Here's my FANUC robot. And when I was saying we make the connections for you, we literally make the connections for you. This is what your architecture would look like. And we make all these connections, and then you just set up your communication, you eat your IP addresses and so on. And we literally do 90% of the work. There's a little bit that you have to do. You have to establish your e-stops, set your IP addresses and things like that. But it is really a nice setup. So now with that, we can open it up for questions. I think we're right at 10:30.
Okay, thanks, Russ. Yeah, I'm gonna unmute everybody now. So if anybody's got any questions they want to just go ahead and ask, feel free. And it looks like everybody got remuted. If you could see your mute button, feel free to unmute yourself. Any questions? Also the chat box. We kind of purposely went over, or didn't go over specifics regarding the robot standards. We can answer questions based on that. Sometimes those might be a little bit longer of conversations, I think. But if you have questions about specific standards or do's and don'ts within, robots and collaborative robots in particular, that's why we have Russ on board here, because he's the safety application specialist, so he knows a lot about that. So yeah, feel free to ask any questions, and we can hang out as long as we need to.
Yeah, and another note that is, if you are looking at upgrading any of your robots or need help with this, I have demo equipment. I have equipment, and we, at least in Wisconsin, we're open for business. We have sanitation procedures. We have health check, checking our temperature every day. So we're ready and open for business if you need us face to face. If you're not ready for face to face, I've got the webcam and I'll do my best. And I'm here, we're all here for you to help you deploy your, keep your factories running, or, get systems going, or get codes out. So just keep that in mind, that at least from our standpoint, I'm open for business.
Russ, can you hear me?
Yes.
I have a question. So you mentioned that the recommended way of connecting the robots to making the whole architecture is with the SIP safety. The question is, do customers need to use a controller that's SIP safety capable, or can SIP provide a solution on their own?
We provide a solution, and so the answer is yes. And remember when we looked at, maybe I'll share my screen again. In the, did I share my screen? Screen 2. So this is our controller here is the SIP safety. So this is the safety controller. Can you see the screen? And then this is your Ethernet SIP safety network. So our controller has the Ethernet SIP safety master built in. So, and you do need to have that.
So customer doesn't have to purchase expensive controller. They can purchase one from us, which is very cost effective, correct?
Right. Yeah. As a matter of fact, it comes as part of the kit. Yep. It comes. Yeah. That's the heart of the kit, and it's very inexpensive. You don't need a Rockwell safety controller or anything like that to make this work. We do it all for you, and we do it all over the network. Now, if you have like a Rockwell system platform, we communicate to that. If you want to, we can show it on here. Our controller has 2 ports on it, the Ethernet SIP safety, so it can communicate to the robot, can communicate to the laser scanner all over the network. And if you wanted to, you could send informational data to your Rockwell PLC over Ethernet IP as well. So it's a very versatile system, and we include it all in as part of the package. So you don't have to buy anything separate. That was a great question.
Yeah, I think one good thing maybe to point out too is that obviously there's less connections. It's maybe even a simpler system. You have the SIP safety, and SIC has that capability, but on your robot or your PLC controller would still have to have the capability to talk that network as well.
Right. Yeah. That's the assumption, is that you have, if you have, I think, Yaskawa, KUKA, FANUC, those, I think all 3 of those work over Ethernet SIP safety. Then that's when you would use this system. And it's really nice because you have your CPU, and then this is your cloning module. So if anything ever did go wrong, your program is backed up. And this is your Ethernet SIP safety module. You can see I've got 1 cable coming out of there, going into my laser scanner. This would go up to my robot. And I'm actually communicating through my laser scanner, because my laser scanner's got 2 ports on it. So I can get into my whole architecture really easy. And it's really a clean way to go, especially when we write the program for you.
Yeah, but if you don't have the SIP safety communication on your robot, we still have a solution for that as well. So
that would be this
version.
Yeah, that would be this one, and it's basically doing the same thing. It's got your CPU, and then it uses IO modules, and then it has safety relays on the end, and that would tie into your protective stop and your everybody calls those stops different. The protective stop and the safe stop, they would call it, or emergency stop. And that's what you'd want to make sure you have. And preferably a safety rated monitor speed would be nice. Then you've got a really good solution.
Right. Yeah, I've seen in cases with collaborative robots where you have a collaborative stop, which is not really stop.
Right.
It's when it actually goes into a slower speed mode, and then say if there's nobody in the area, it can actually work at a faster speed, more like an industrial robot.
That's exactly why the UR variant is, which, you know, UR was the first people to do the collaborative, and that was our first kit, because, you know, at a glance, people think, oh, it's a collaborative robot, therefore it's inherently safe. No, well, it could be, but you'd have to do your risk assessment and make sure. But then the next thing that I hear most often is, oh, my robot's too darn slow, because it's always in collaborative mode. And I say, yeah, that's why you apply our system. When the person backs out, the thing can go to full speed, and it's only in the collaborative mode when somebody's in the area. That's the whole idea behind the speed, and that's how this whole thing got started, was with collaborative robots. And then we branched out into, as the industrial robots got more sophisticated, we found that we could use them for industrial robots as well.
Good. All right. Anybody else want to throw out any questions, comments, thoughts on this? Any application questions? Okay. Well, if anything does come up, you know, we'll be reaching out to you. Hopefully we got something out of this, and now we're figuring out how to safeguard everything in our plan and any kind of robots we're looking at. But yeah, if you think of anything, please feel free to reach out to All Control, and we can help. We'll get SICK involved if we need to. And then, yeah, like I said previously, we're going to be doing a couple more of these, mostly focused right now in May and June on safety applications and safety products. So look out for invitations on for those, and hopefully we'll add some value.
There's one other quick thing that I always like to point out. People always ask me, Russ, how do I find my laser? We have a little tool here that's is designed to pick up infrared laser light. So you can see I'm picking up that laser and this laser. That one's actually hitting here. So a nice little tool. It's all battery operated, rechargeable. The idea is that these lasers typically are mounted 300 millimeters off the ground. How do you know where this laser beam is hitting, especially when you're out 9 meters? This is just a tool that we use, and it's got a little measuring stick on it, so you can set it at 300 millimeters and make sure that your laser is hitting in the right spot. You can see that top one is hitting right where I want it to be hit. Oh, you probably can't see that, but it's just a tool that we have that I wanted to point out, that people ask quite often about, and they're not super expensive, but it's nice to have in your plant, or if you're doing validation, you certainly would want to use one of these. There, now that I got my mess all going here, that's what we have for today.
Okay, well, yeah, if there's nothing else, thank you everybody for joining, and hopefully we added value, and look out for future invitations to come.
Yes, thank you. I sure appreciate everybody's time.